Hi, I am back. So are you. That's good. I'm sure after reading the concept in the shot there, you've been able to understand that concept, but now you want to ink it with the help of a sum so that all of that is perfectly there with you, well assimilated for a long period of time. That is so good. Now, in place of giving you people a single sum, I'm going to give you people two sums so that this concept be very well inked with you people. Now, first, the concept quickly. Now, when you have a circle and it is to be represented in the parametric form, you require to know from where are you going where. So, firstly, we had x squared plus y squared to be equal to r squared, which was the standard form or the simplest form. The center of the circle being at the origin, and as such the distance of any point of the circumference x comma y was given by x minus 0 square plus y minus 0 square to be equal to r squared, the radius square. Now here, to do it, when we talk about the standard form, now to be represented in the parametric form, what do is, again, we make the x-axis and the y-axis, and the intersection, the origin, is where the center of the circle is. Now, if we consider a point x comma y on the circumference and join it to the center of the circle and find out the angle of this radial line with another radial line drawn from the origin on the x-axis, this becomes the angle theta. This is the parameter. Now, theta varies from 0 radians to 2 pi radians. Now, if you talk about the parametric form, it is given by x to be r cos theta and y to be r sin theta. As you see, r here is a constant, the radius, which will be known, and theta will vary. As theta will vary, we will get different points. So if you have a point which is here, for that obviously theta is different, and if you have a point here, for that theta is different again. So by keeping different values of theta, you will get different coordinates on the circle, right? So now children, after you've understood the parametric form, so there is a question for you people. I'd like you people to quickly give it a try, and after that I'll be discussing the sum with you people. So I will give you people just 10 seconds for trial, and I can tell you, you'll be able to do it in lesser time. Make sure that you're seated in a table and chair all by yourself so that there is no disturbance. And when I'm explaining, make sure that your focus is exactly where I am. So if I am at E, you have to be at E. If I'm at C, you have to be at C, so that you can understand perfectly. For your better understanding, I will also give you a second explanation so that everything gets perfectly clear. But make sure to be with me and to be in this position that I told you, on a table and chair. For sure, you will understand each and every concept. Now children, continuing with the sum, here we've been given that there is a parametric equation to which the standard equation has to be converted to, and we have the equation to be 2x squared plus 2y squared is equal to 13. Now children, here we can take 2 to be common outside, and then we have x squared plus y squared is equal to 13. As such, here we will now have x squared plus y squared, which will become equal to 13 upon 2. Now, if we take a root of this and square it, don't you think that this can now be compared with our standard equation? Yeah, it can be. So comparing it with our standard equation of a circle, or simplest equation of the circle, that is x squared plus y square is equal to r square, we will now get the value of r to be equal to root of 13 upon 2. A pretty crude value, but whatever it is, this is the radius of the circle. Now children, to write it in the Cartesian, the parametric form, this was already in the Cartesian form. In the parametric form, now we actually are just going to get x to be r cos theta. So in parametric form, we will now have x to be equal to r, which is root of 13 upon 2 cos of angle theta, and we will have the value of y coordinate of any point on the circumference of the circle to be root of 13 upon 2 sine theta, right? So these are the two two coordinates, the x coordinate and the y coordinate, or in other words, the abscissa and the ordinate of any point on the circumference of the circle. Now that it has been written in this format, this is actually the parametric form in which you had to bring your answer. Pretty simple. Okay, now children, here I will just quickly discuss the sum all over so that if there is any doubt withstanding, all of that is gone. In the question, you've been given to find out the parametric equation of a circle 2x square plus 2y square is equal to 13. Now I'm sure you people must be having a question popping in your head, that is, why did I take this 2 common outside? Moreover, whatever is common, always take it common outside, right, and try and remove it. In this case, it was removed because the equation that we are wanting to bring from to the parametric form is actually the Cartesian form, which is x square plus y square is equal to r square. And since this is not in that form, so that's why we've taken this 2 to be common outside and taken it to the other side, right? And thus here we have x square plus y square is equal to root of 13 upon 2 whole square, as we will get 13 upon 2, right? And since we want it in the form of r square, so squaring this will give us 13 upon 2, that is the value of r will become equal to root of 13 upon 2. Now comparing, obviously we will get the value of r. After that we can very easily write the parametric form, which is x to be r cos theta, that is root of 13 upon 2 cos theta, and y to be equal to root of 13 upon 2 sin theta, that is r sin theta. So this is what had to be done in the sum. Very simple, isn't it? So how many children were able to do this in the stipulated time, that is 10 seconds? If you were one, do write it. And what new you've learned, right? And what is something special that you would like me to do for you so that you can understand more of maths? Do tell that to me. I will leave a link in which you can get and write all that you require from me so that I can help you, so that you can have your maths, say, one where you can get 100% marks. Okay children, so now, like I told you people, I'll give you a second sum. So this is the second sum to strengthen you further in this topic. Give it a try.